In this lesson, we're going to introduce slope. And so let's start with a simple definition. So slope really just describes how steep an incline or decline is. So the higher that ratio you have for slope, that will mean your slope is actually steeper. So something like this slope or mountain that this person is skiing down would have a very high ratio of the rise in association to the run, because that is a very steep decline right there. So we encounter slopes in many different ways every day as we're walking or driving or skiing, just up and down. Everything that has an incline or decline can be calculated to have a slope. So slope is going to be referred to as a rise over run, where we're looking at how far we're changing vertically and comparing that to how far we're changing horizontally. So that's your run. So to calculate a slope of an incline or decline, we can count the rise and divide it by the run. Your rise is your up and your down. So your rise is referring to, if we think about on a grid, coordinate grid, if rise is up and down, that refers to our y-axis going up and down. Side to side is going to be our run, which is our x-axis. So our rise is going to refer to the y's, and our run is going to refer to the x's. And we'll get into that a little bit further when we get the actual formula. But if you rise up, you are moving in a positive direction, so that will be a positive value. If you rise down, you're moving in a negative direction, so that would be a negative rise. So we can have a rise to be positive or negative. And same with our run. If you think about the number line, if you're moving to the right on your number line, you're moving more positively, so those are positive numbers. If you run left, then you're going into the negative direction, so that would be a negative run. And we always need to make sure to reduce a slope. All right, so let's take a look at this roof. And so this is a side view of a roof, and let's find its slope. Now, when you're calculating your slope, you're going to look for your rise and your run. So it means that we should start at one point on that slope, anywhere really. Because we're given this triangle here, we're going to start at one of the endpoints of the roof triangle portion and count rise and run over to the other. So I'm going to count the rise first. So what I'm going to do is go up until I'm level with the height of that roof. And I notice over here I'm told that it is an 8-foot rise. So I've risen 8 feet, so that means in my rise over run I'm going to have an 8 over, and then my run, I went to the right, so that is positive, and that run was 12 feet, so my run is 12, positive 12. We'll then need to simplify this, so divide by 4 to get a slope of 2/3. Now it doesn't matter where you start from. Let's say I started here. I would calculate my rise, but in this time I'd have to go down to get my rise. So let's say I'm calculating from that point. My rise would be a -8, and then my run would be a -12 because I went left. So this still reduces to the same thing. And so our slope for this roof is 2/3. All right. Let's find the slope for this decline that this skateboarder is going down. So again, choose any point to start from. It can be either of these that we're given calculations for as far as rise and run. I'm going to start here on the left. So I'm rising, that's the up and down movement, 18. So because I went down, that is a rise of -18. And then I'm running to the right, a positive 24. So we'll need to reduce this to get -3/8. Again, you could have gone the other direction and rise positive 18, and then your run is -24. So we're still simplifying to, and I did not do that right. Ooh. 6. this should be a 4. I don't know what I was doing. Sorry. -3/4. My apologies. Okay. Anyway, so we reduced by 6 up top and bottom. Okay, so that has a slope of -3/4 no matter which way you go. All right, so let's take this now to actually lines in our coordinate grid. So when we're finding a slope of a line, we're going to use points on that line and count the rise and run using those points. So notice we have the point -2, -4, and the point 2, -1 given to us. These are 2 points given to us, so we're going to use the ones that are given because they are accurate. And you'll notice if I tried to use a point over here, it doesn't exactly intersect with the grid at a nice clean intersection, so that would be a decimal for that point. So we're going to use the ones that are given. So to get from the first to the next, I have to rise, and here I rose 1, 2, 3, so that rise is a +3. And then I run to the right, 1, 2, 3, 4, and that's a +4 for the run. So 3/4 is the slope. Again, if you started at this corner and went rise -3, run -4, you're still simplifying to that same slope of 3/4. Okay, try this one on your own. Okay, so we rise -1, we run +3. So this slope is -1/3. Okay, so let's push this a little further. Slope is a rate of change. We know that slope we've just talked about is how steep a line is. So if a slope is going up from left to right, we should notice that it's going to be a positive value. So let's look at that. If I were to put a little man here on the left side of my line, notice he would be climbing up to get to the other side of the line. Because this is a positive increasing line, I should notice that the slope is in fact positive, going up from left to right. Here on this one, if I put my man on the left side, again, we always put him on the left, and look at how he would walk along this line, he'd be going down. So this line, because it's going down, should have had a negative slope, which it did. So back to this, if a slope is positive, that tells you your line should be going up from left to right. And if your slope is negative, your line should be going down from left to right. So that's going to be a nice way to quickly check at the end that your slope actually makes sense with your graph. And we know that we can find our slope by calculating the rise over the run. Another way to think of that, though, is that your rise is your change in the y coordinates, as we were beginning to touch on with the coordinate grid, and the run is your change in your x coordinates. Well, if you know that, then that's how we're going to be able to derive the formula for finding a slope, because we won't always have coordinates to count grid markings of. We can find any slope by subtracting the 2 y's and dividing that by the difference of the 2 x's, or the change in your x's. So here it's written as y2 minus y1. This refers to just your second y value. This refers to your first y value. It's important to note this is very different from y squared, right? These are not exponents. They are just defining which y's we're using. But essentially, you subtract your y's, and in the same order, you subtract your x's and divide that out and simplify. Okay, well, if you're in class, we'll go over this song together, but let's do some practice with finding slope. So here we're given a line in a coordinate grid, and we're given 2 points that have been plotted on that line. So to find the slope, let's first state what our 2 points are. So this one's -2, 1, and this point is 0, -3. So we need to subtract the y's and then subtract the x's. Just like it did not matter which way if you started from this point or from this one, it doesn't matter which x's are your first x's or your second x's, or in your first y or second y. That doesn't matter. But what we will do is label our first point as x1, y1, and our second point as x2, y2. We'll label them that way to help us keep track of which values we're subtracting first. So if you'll notice, our formula says y2 minus y1. Well, my y2 is over here, so I'm going to put -3 first, and then I'm subtracting my y1, my first y, which is a value of 1. Then in the denominator, we're doing x2 first, which is 0, minus x1, which is -2. So minus a negative is really positive, or plus. So you could write it that way as well. The biggest thing I need you to notice is that it really didn't matter if this point was our x2, y2, and this point was our x1, y1. What mattered is that if I pulled the y value from this point first, then I had to pull the x value from this point first. So really you're just deciding which point am I pulling from first, and just stay consistent. Once you've done that, you can simplify your slope. And so this fully reduces to a slope of -2. Here it's not written as a rise over run, so if you did want to see it as rise over run, you could write it as -2 over 1. So either of those for your slope would be acceptable. Okay, so here we're going to find the slope between these 2 points, and this time we do not have a coordinate grid. So what we'll do is we'll start by labeling one of these our x1, y1, and the other the x2, y2. Again, that doesn't matter. You're just determining which point you're going to be pulling from first. So I'm going to show this both ways. So the way that I've labeled it is over here to the left. Okay, so I labeled 2, 5 as my second point. So I'm pulling the 5 as the y first and the 2 as the x first. You'll notice those are first in my subtractions. So if you had labeled these and reversed it and said this one's actually your x2, y2, and this one's actually your x1, y1, then the right side is how you would be filling in your slope formula. You'll notice that no matter how we do this, as long as you're keeping your signs correct and you're pulling consistently from the same point first, you're going to get the same slope. So both sides simplified to a 9 on this side, or a -9 in the numerator. And whatever you got in the numerator, the sign will just be, we'll get -1. So I had positive up top. My denominator is negative. Here I have negative up top, but my denominator is positive. Regardless of how you do that, it's still a positive divided by a negative is a negative. So our slope is -9 over 1, or you can just write that as -9, meaning we would rise -9, go down -9, then over 1 to the right to count out our slope on that line if we were to graph it. All right, so let's apply this a little further. We have our slope formula, and let's look at a problem where we're given the actual slope, but we're missing one of the coordinates. So we're going to find the value of r so that the line through r6 and 10, -3 has a slope of -3/2. So we want to draw a line that has a point at 10, -3, so somewhere like that, and then at somewhere r6, but we want this line to have a slope of -3/2, meaning we would rise down 3 and over 2. So it's going to look something like this. Oh my goodness, so it's going to look something like that. Okay, but we're looking for what value for that x would make this scenario true. And so what we'll do is we'll just substitute what we know into our equation and solve for what we don't. So I'm going to start by setting up my slope equal to the different parts subtracted. So my y's were -3 and 6. So you'll notice I just pulled -3 first and said negative 3 minus 6, which meant that my 10 had to go first in the bottom from that same point, minus r. I would highly recommend that you write your slope as a fraction, even if it's given to you as a whole number or integer. Put it as a fraction, so that means if this had been, pretend like a slope of 5, in your equation I would write it as 5 over 1, so write it as a fraction so that we can cleanly just cross multiply to solve for that r value that's missing. So set up your cross products equal to each other. This negative 3 minus 6, you can certainly simplify to a negative 9 before the cross multiplying happens. Okay, but on the other side, when we set up the cross product, we're going to have to do some distribution of negative 3 times 10 and negative 3 times negative r, which becomes plus 3r. Then we solve for r, so I need to undo my operations, adding 30 to both sides, divide by 3, and we get that r's value will be 4. So the value of r that would make this scenario true is 4, so that's the x value for that point. Okay, so with a problem like this, we fill in what we know and solve for what we don't. So why don't you try another one of these on your own? Once you're done, click pause, try it, then click play, and we'll come back together and check it. Okay, so you've just done this problem. It had a slope of 2, so again, I would set that up as 2 over 1, so that when I cross multiply, I have something to multiply with. And then after the distribution and simplifying and isolating of r, we should get r's value to be 0. So the point would become negative 1, 0. That would make this true. Okay, we can find a slope for a set of data, and remember that slope is really just a rate of change. So if you're given data in really many different forms, table is going to be the most common form we'll find data in, but even as a graph, we're going to be looking for the rate at which that data is changing. And so if we remember that when you're given tables, the first column's your x, the second column's the y, and we also bring in the fact that slope is found by finding the change in y's divided by the change in x's, we can quickly find a slope from a linear data table by finding the change in our y's. So here we're going up 4 each time, and we do want to make sure it remains consistent. If it's not a consistent change, then we can't find the slope. But here, let's see, here we're going up 1. We do notice that the change in y's remains the same at plus 4 each time, and the change in x's remains the same at plus 1 each time. So if you have a constant rate of change of your y's and x's, we can write the slope of the entire set of data, or the rate of change of the whole set of data, as either 4 over 1 or just 4, because this was our y's and this was our change in x's, so change in y's goes on top, change in x's goes on the bottom. All right, try this one on your own, finding the slope of this data table. Click pause, and then when you click play, we'll check together. Okay, so you found your change. So we were increasing by 2 on the x's each time, and by 78 on the y's each time. And so that gave us 78 halves as our slope, and don't forget to reduce to 39 over 1. You may have also written that as just 39, which would have been acceptable. 2 more for you to try finding the slope of, and then we'll check together. So click pause and find these out. Okay, so let's check what you found as the slopes for these tables. Take a quick look there. So here we are adding 10 each time. Here we're adding 1. Here we're adding 5 each time, and up here 25. Another way you can do this is to look at these as points. So to see that this is the 0.26 and this is the 0.731, and as long as you're recognizing this change remains constant, you could just use any 2 points and fill those parts into your slope formula. So notice that's actually how I did this problem. So I did my y's, 31 minus 6, over the difference in my x's, 7 minus 2, and that got me to the same slope as if I were counting it out. Okay, and a quick little review here to remember that positive slopes indicate that your line should be going up from left to right, and negative slopes means your line should be going down from left to right. So anytime you find slope, it's important at the end, especially if you have the graph, or if you have the graph to compare it to, that you're comparing it to how the graph actually looked. If you have a positive slope and you notice your line's going down, that means you need to check your signs. But let's move into looking at slopes of horizontal and vertical lines, because these get a little bit different. So remember, a horizontal line is a line that is flat from left to right. These will have a slope of 0, and this is something you'll need to learn and memorize if you're not able to find it on your own. But the way to figure out that a horizontal line always has a slope of 0 is, let's pick any 2 points from this line. So let's pretend like that's the 0.23 and 5,3, okay? If I went and found the slope of this line by subtracting my y's and subtracting my x's, I would reduce or get a slope to simplify to 0 over 3. Well, 0 divided by 3 is 0. And so what you'll find with horizontal lines is that their slopes are always 0, because you always get your y value as the same thing. So anytime we're subtracting something by itself, it becomes 0. So y is your number, would be the equation of the line. So for the example that I just wrote, I stated that I pretended that the y's were all 3. So remember, our horizontal lines have an equation of y equals 3. That number is where it crosses your x-axis. So I made that up, saying it was 3. All right, let's look at a vertical line. A vertical line will always have an undefined slope, and let's look at y. Let's pretend like this is the point 4, 1, and this is the point 4, 10. Okay, so we'll subtract the y's over subtracting the x's, and we get 9 over 0. When you see 0 in your denominator, hopefully you recognize that that's not possible. We can never divide something into 0 parts. So anytime we divide by 0, it is actually considered undefined or not possible. So if you have a vertical line, it has an undefined slope. And so if you're ever told to find the slope of a vertical line, you should be able to understand that you would state it's undefined. It really doesn't have a true value. Okay, the equations for vertical lines are always x equal to the number. So in this example, I claimed that it was crossing the x-axis at 4, so this line's equation would be x equals 4. All our x's are the same. And a couple last minute reminders, last things you'll need for your homework. Slope is never written in decimals or with decimals in it. So we have gone over how to get rid of a decimal in a fraction. So you would multiply top and bottom by 10 or 100 or something like that to get rid of decimals, but slopes never have decimals in them. They are a ratio comparing two whole numbers, which is why we write them as fractions. And we'll always leave it in a simplified improper fraction form, meaning that we will not give mixed numbers. Okay, because a slope is a ratio comparing two whole numbers, if you were to turn an improper fraction into a mixed number, that doesn't really give you anything to do with, we don't know what to do with that whole number out there. So leave it improper, because that tells us the rise over the run. Regardless of proper and improper, you just leave it that way, simplified. And that's it for our lesson.